Hello guys, my name is Bino, and in this video I'll be going through the following question, which is on limits and continuity. Question 1.1.1, we have to evaluate the limit of x multiplied by ln x as x approaches 0. When we try to substitute for x, we get 0 multiplied by ln of 0, and ln of 0 does not exist. But what is the behavior of the graph of ln x as x approaches 0? We have the graph of ln x, and as x approaches 0, as it approaches this line, this graph will continue to go down to negative infinity. So as x approaches 0, the ln of x will approach negative infinity, and the function x as x approaches 0 will just be equal. So we have the undeterminate form 0 multiplied by negative infinity, so we have to use the L'Hopital rule. The L'Hopital rule states that if you have the limit of f of x divided by g of x as x approaches a, this will be equal to the limit of the derivative of f of x divided by the derivative of g of x as x approaches a. In order for us to apply the L'Hopital rule, as we can see, we apply it to a quotient of functions, to a fraction of functions. And what we have here is a product of functions. So we first convert x multiplied by ln x in the form of a fraction. So we have the limit of x multiplied by ln x as x approaches 0. A multiplied by b will be equals to b divided by 1 over a, or a multiplied by b, it will be equals to a divided by 1 over b. So we can express the limit of x multiplied by ln x as the limit of ln x divided by 1 over x as x approaches 0. So now we have a fraction of functions, so we can now apply the L'Hopital rule. But before we do that, let's express this 1 over x. Let's write it as x to the power minus 1 so that it can be easier for us to differentiate this. So the derivative of ln x, will be equals to 1 over x. And the derivative of x to the power minus 1 will be equals to negative x to the power minus 1 minus 1. And we are saying that x is approaching 0. We can express 1 over x as x to the power minus 1. So we are going to take this 1 over x and express it as x to the power minus 1. So this will be equals to x to the power minus 1. As we are trying to simplify this, we have negative x raised to the power minus 2 as x approaches 0. And from here, let's take x to the power minus 2 from the denominator to the numerator. When you take x to the power minus 2 from the denominator to the numerator, the exponent is going to change sign from negative 2 to positive 2. And this is as x approaches 0. We have the limit of negative, so the bases are the same. So if the bases are the same, we add the exponent. Negative 1 plus 2, and this is as x approaches 0. We have the limit of minus negative 1 plus 2 is equals to positive 1. And this is as x approaches 0. From here, let's substitute 0 for x. 0 multiplied by negative will be equals to 0. So the limit of x multiplied by ln of x as x approaches 0 will be equals to 0. Question 1.1.2, we have to evaluate the limit of ln of 2x divided by ln of 3x as x approaches infinity. This will be equals to infinity divided by infinity because as x approaches infinity, y will also approach infinity for the function y is equals to ln of 2x, and same applies for the function y is equals to ln of 3x as x goes to infinity, y will also go to infinity. That's why we have infinity divided by infinity, so we have to use the L'Hopital rule. So the L'Hopital rule states that the limit of ln of 2x divided by ln of 3x as x approaches infinity, this will be equals to the limit of the derivative of the numerator divided by the derivative of the denominator as x approaches infinity. So the derivative of the ln of 2x will be equals to 1 over what's inside the ln, which is the 2x, derivative of what's inside the ln, which is equals to 2. So the derivative of the 2x is equals to 2. We divide this by the derivative of the denominator, so the derivative of the ln of 3x will be equals to 1 divided by what's inside the ln, which is 3x, multiplied by the derivative of what's inside the ln, which is equals to 3. The derivative of the 3x is equals to 3 as x approaches infinity. We can notice that that 3 and that 3 will cancel out each other, and also that 2 and that 2 will cancel out each other. So this will be equals to the limit of 1 over x divided by 1 over x as x approaches infinity. That 1 over x and that 1 over x will cancel out each other, and this will be equals to the limit of 1 as x approaches infinity, which will just be equals to 1. So the limit of ln of 2x divided by ln of 3x as x approaches infinity will be equals to 1. Question 1.2, we are given the function f of x is equals to 3 divided by e raised to the power 2x minus 1, and we have to find the value or values of x that will make the function to be discontinuous. We know that division by 0 is not allowed. So whenever e raised to the power 2x minus 1 is equals to 0, then this will be equals to 3 divided by 0, and division by 0 is not allowed. So from here we have to solve for x. We take the negative 1 to the right, it's going to change sign from negative 1 to positive 1, and from here we introduce ln both side of the equation, because we know that ln of a raised to the power b will be equals to b ln of a. So we are trying to remove that x from the exponent so that we can solve it properly. So introducing ln, and what we do on the left we also do on the right, so we also introduce ln on the right side of the equation, and this will be equals to 2x minus 1 multiplied by ln of e, and ln 1 is equals to 0. We have 2x minus 1 ln e is equals to 1, and 1 multiplied by 2x will just be equals to 2x, and negative 1 multiplied by 1 will be equals to negative 1. We take the negative 1 to the right, it's going to change sign from negative 1 to positive 1, and from here we divide both sides of the equation by 2. That 2 and that 2 will cancel out each other, so x will be equals to 1 over 2.